Okay, this problem was posted over 10 years ago. I have a student who stumbled upon it and asked if I could help her solve it. So that's what we're doing. The problem is posted says to use the shell method. Probably no one answered this 10 years ago because I think this condition was missing. So this is the region that we're going to revolve about the x-axis. This curve right here kind of looks like a straight line, but it's actually the graph of y equals the square root of x plus 12. This line is a line, the line y equals x. If we use the washer method, it's quite a bit easier. We're going to say the outer radius squared minus the inner radius squared. So the outer radius is the length of that red segment, a typical outer radius, which would be the square root of x plus 12. If we square that, we get x plus 12. So there's the outer radius squared minus the inner radius squared. Well, the inner radius is just x because y equals x. So there's the inner radius squared. And if you found an antiderivative multiplied by pi, this is what you'd get, an exact answer. Using the shell method, it's quite a bit more complicated. You see this light dashed green line here? That divides this region into two parts. We're going to see that a typical shell for this region looks like this, but a typical shell for below that green dashed line looks like this. So let's go to the board 2 and see what that looks like. So for the region above the green dashed line, this is the height of the shell. And remember, for the shell method, a typical shell is parallel to the axis of revolution. So we want to take the x-coordinate at the right minus the x-coordinate at the left for the height of the shell. And that's what this is right here. So in other words, I solved y equals the square root of x plus 12 for x, because this is a horizontal distance. So if I square both sides and subtract 12, the distance from here to here, from here all the way out to here, to here, is y squared minus 12 for every y between. This point actually has a y coordinate of 2 radical 3. So we're going from 2 radical 3 up to 4. And so the height of the shell is the y coordinate at the right, of the x coordinate at the right minus the x coordinate at the left. That's the expression for the height of that shell. And then we want to multiply that by the distance from the axis of revolution to the center of that shell. Well, we're just going from here up to here. That's y. So this is the distance from the axis to the center of the shell. This is the height of the shell. And we're going from 2 radical 3 up to 4. And then multiplying that by 2 pi. And that's what we get for the volume of that volume of revolution. And we get this if you want an exact answer. I'll leave that to you. And then for this region down here, that's a little bit easier. The height of the shell is this length of this green segment. Well, that's the x coordinate at the right, which is just y, because y equals x. And we assume that we're going from x greater than or equal to 0 for the region. So, and the height of the shell is just y. The distance from the axis of revolution to the center of the shell is just y. So there's y times y squared. This time we're going from 0 up to 2 radical 3 for this region right here. That's where the shells occur. And so if you evaluate that, you get this 87.0623. Add those together, we get what we got with the washer method. If we evaluate the second integral exactly, we get 16 pi radical 3. If you add this to this, the radical 3's disappear. 48 radical 3 minus 48 radical 3. So we get the same exact answer. There you go. Hope that helped. If you have any questions, post a comment.